We're continuing with Chapter 17 and actually finishing it up today. We're still using the binomial model, but there are times when using the binomial model to find probabilities really isn't feasible. Therefore, we have the normal model to the rescue. I know you guys are excited about the use of the normal model again. Suppose that the Tennessee Red Cross anticipated the need of at least 1,850 units of O-negative blood, and they will collect from 32,000 donors. How great is the risk that the Red Cross will end up falling short? So in other words, what's the probability that they don't get at least 1,850? So in this case, our sample size is 32,000. The probability of success, because we're still using the blood example, is 6%. So the probability of getting exactly 1,850 units is given as 32,000, choose 1,850, times the probability of success, 0.06, raised to the number of successes, times the probability of failure, raised to the number of failures. It seems like we should be able to do this. However, no calculator will do 32,000, choose 1,850. That combination is just too large. I actually think that it may be possible on the nSpire now, but originally, not so much. The other issue is that this is for exactly 1,850 and they need at least, so they need 1,850 or more. So now we're looking at literally millions of different combinations. What we can do is we can calculate the mean and standard deviation. The mean, using the binomial model, is n times p, number of trials times the probability of success, which in this particular situation would be 32,000 times 0.06, which is 1920. So on average, if we have 32,000 donors, we should expect to have 1,920 people with O-negative blood. The standard deviation is calculated as the square root of n times p times q. So the square root of the number of trials times the probability of success times the probability of failure, which in this case ends up being 42.48. Using the normal model, we can find the z-score and then use the z-score to find the probability that x is less than 1,850. Remember, these problems are often easiest if we draw a picture. So I'm going to draw the normal model. So we put our mean, which is 1920 right here. We're looking for less than 1,850. Well, 1,850 is going to be about here. I'm looking for less than that, so I'm going to shade that area. So then I calculate my z-score using the formula x minus the mean over the standard deviation. So this is 1,850 is my observed value minus my mean of 1920 divided by the standard deviation of 42.48. This gives me a z-score of negative 1.648. Then we use our z-score to find the probability. We can do this either using the table in the back of our book or normal CDF on our calculator. The probability that x is less than 1,850 then equals 0.0497 or 4.97% of the time. This means that there is a 4.9% chance that the Red Cross will not meet their goal. So it's nice that we can use the normal model, but we can't actually always use the normal model to make estimates of binomial probabilities. The normal model is only appropriate for a symmetrical histogram. The histogram is typically only symmetric when the number of success is large. It actually will always work, or normally will work, if we expect at least 10 successes and 10 failures. This is called the success-failure condition, which states that a binomial model is approximately normal if we expect at least 10 successes and 10 failures. So if you are going to use the normal model to calculate a binomial probability, you have to check the success-failure condition so that way you know you can actually use the normal model. The way we check this is by multiplying your number of trials times your probability of success and the number of trials times the probability of failure. So this one will give you the number of successes, and as long as it's greater than or equal to 10, you're good. This will give you your number of failures, and as long as it's greater than or equal to 10, you're still good. We can only use the normal model to approximate probabilities when we're looking for a range of values. So in that case, we wanted to know the probability that we were going to fall short of 1850. That means that that could be anywhere from 0 to 1,849. That is a range of values. Therefore, it's okay to use the normal model. You cannot use the normal model to find an exact probability. This is it for all of Chapter 17. We're going to do examples tomorrow in class of how to calculate binomial probabilities using the normal model to make sure we're comfortable with that. But that is it for tonight, so have a good night.